Okay, so the system itself is just as simple as can be. Out there on my right wing, or in the right wing, I have, looks like 9 oxygen bottles that are going to flow through a regulator, through the hose right here. This is, I assume, the regulator right here, through the hose, around this hose, the air breathing hose. I connect my mask right there and get breathing oxygen. Now, the regulator should be, I would have thought at this altitude that the reg would have been providing me with oxygen right now. I'm at going up through 5,000 meters or so. Let me take it further up in the climb real quick, and I'll see at what point I start to breathe oxygen. I should get this blinker going from white to black as the regulator starts to provide oxygen through the system and I start to breathe it. So yeah, let me climb out a little bit. I'll be right back once that starts to happen. Okay, so I'm climbing up above about 22,000 feet. What's that, about 7,300 meters or so? And if it were going to happen, it would have happened already. I've got my oxygen flow valve open, which then provides oxygen from the bottles to the regulator. And one thing I can tell you before I stall it here, it gets squirrely. It's actually a lot of fun to fly at high altitude, but if you let the speed bleed off, it's really squirrely. I've got to put in a lot of rudder control to keep it coordinated. It's just, it's accurate. It feels like something at high altitude, but it takes a lot of attention to fly. So forgive me if I stall it here. But okay, so oxygen is flowing to the regulator. Now the regulator works by virtue of a diaphragm. It's just going to expand and contract based on the ambient barometric pressure, and the expansion and contraction of the diaphragm is what allows the oxygen to flow into the system, get mixed with ambient air, and then flow into the mask. Now, I was expecting this gauge to start blinking once I start breathing in and out. I think either I am actually breathing oxygen because I think that because the pressure gauge is decreasing as I increase in altitude, but that could also be due to the decrease in temperature having a corresponding effect of decreasing the pressure in the oxygen bottles. So if it were going to happen, it would have happened already. But yeah, like if I close it off, then the pressure being fed in goes down to 0. Open it back up. Pressure as registered right here going to the system is back up, and I've just got no blinker going right there. I think everything's fine. I'm not... I think I would have started to get hypoxic and have all those little associated effects start to happen if the system wasn't working, but yeah, apparently the blinker just isn't working, but it's an open beta. Oh well, no big deal. So let's see here. Let me pull it back from the... I guess I was already pulled back on my throttle a little bit to sort of a the loiter or the max performance setting, just above 1 on the manifold pressure gauge. I wonder, and I'm starting to think about what was happening back down there, where that point where I had the throttle pulled all the way back, yet the manifold pressure was still like way up. I'm not sure exactly what the caused that. Well, it's doing what I'm expecting right now, but I expect that could have had something to do with that automatic control, part of the automatic control system in the engine, but it's nothing wrong with it. I just didn't fully understand why it was staying where it was, but I do suspect it was the automatic system sort of carrying over into that based on the prop pitch. So let me start to look around and think about some more systems. Now, flight controls. These are just basically linkages going to the different flight control surfaces. Like down below the stick, you can see the boot right here, just basically keeping foreign objects out of the system, but it's just a linkage. So if I go right on the stick, the linkages just carry all the way out there to the aileron. Actually, let me bring up the diagram real quick. Yeah, like for example, here's the diagram showing how the elevator controls work. So it's just a linkage attached to the stick, goes back there behind me, and then just connects directly to the elevators back there in back of the aircraft as I'm picking up some contrails. And Pro 2's trying desperately to keep up. 2's probably as close to stalling as I am constantly here. And you can see how the horizontal stabilizer, or the elevator trim works as well. It's just a pulley that goes back directly back to the elevators themselves. There's the rudder, and you can actually see the linkages down here as I work the rudder controls. There to the left and the right of the pedals. So it's all just by feel, no hydraulic boosts or assists. And in fact, the faster I go, and I'll take the nose down and get some speed on the aircraft. And one thing that they did, a change they made to the way the aircraft was modeled at one point, is that the forces that a person could conceivably place on the stick are modeled now. So at low speeds, I can get full deflection. Right there, in the real world, I have my stick full deflection, but you can see how the stick in the cockpit here only goes not even a quarter of the way over, and that's just reflecting how much force is put on the stick right now. 600 kilometers per hour, so I'll pulling out with full aft stick on my real world HOTAS, but it was only coming back just a little ways just due to those aerodynamic forces on the stick. So that's actually very, very cool to see modeled. And one of my biggest problems with not problems, but one of the biggest challenges I had to overcome on the original version of this aircraft when it was just released was that it was so easy to over control the aircraft that you could just get into a turn and not realize how much force you were putting on the stick. And even though a person would not be able to move the stick around fully due to those loads, the aircraft would register full aft stick, and you would end up just over-G'ing the aircraft constantly and just ripping the wings off, where now you really kind of have to work to overstress the aircraft because it only goes as far as a human would be able to push it. Now, the only really hydraulic control systems on the aircraft are the landing gear and the brakes, and that's just for extension and retraction, and then for applying the braking power. And you can see the hydraulic lines going down there to the brakes. Everything else is just done by conventional pulleys and levers and rods, which is kind of cool. And I talked a little bit earlier about the MW50 system, how it increases the engine performance. Now, I guess I'll look at that in a little bit more detail right here. Now, the system is going to automatically kick in once I push the throttle up past a certain point. So I've got it to the normal max setting right there, or normal combat setting of 1.35. So if I push the throttle on up, you're going to see the manifold pressure jump all the way to 1.8 as that water methanol concoction is injected straight into the combustion chamber. You can see the pressure right there of the MW50 mixture system, and as I pull the throttle back, you can see the pressure goes down, manifold pressure returns back to a normal sane amount, and we're right back to flying the aircraft normally. So I was thinking earlier that I had actually considered when I was on the runway disabling the MW50 system just so that I wouldn't have it inadvertently kick in, but I don't think that's going to matter now, because really, as far as I'm ever going to push the throttle up is about to the halfway setting until I want the MW50. So just in the course of normal combat, I would go to about halfway. If I needed an extra boost just to probably run away, but if I wanted to catch up with something, we'll say that's what I'm doing. Then I would, and only then would I push it up. So it's it's almost like an afterburner. Like if you were flying the F-15, you have the full military power, and then you have the afterburner with the MW50. It's actually, I actually like that analogy a lot, even though it does have its flaws, I guess. Now, a side effect of the MW50 system, and this was actually pointed out to me in a comment, it was something that I had never really thought about or never realized. It was kind of counterintuitive to me, but the MW50 system also serves to cool the engine down just a little bit. Now, let me try to demonstrate what I mean there. I tried just a second ago in a part that I'm going to edit out. Maybe this will make a lot more sense. I've got the MW50 disabled to the left with this switch, and what I'm going to do is I'm going to firewall the throttle without the MW50 system enabled. You can see my manifold pressure goes way up. Now, look at that water temperature up there. It's going to go to the peg, and it's just going to keep rising until eventually that's going to burn out the motor. Now let me pull the throttle back, and you're going to see it start to come back down. Now let me do that same thing with the MW50 system. I'm going to firewall the throttle. I've got the manifold pressure up, but you're going to see that the water temperature is, instead of increasing past the peg is going to stabilize right there, and it's not going to overheat and burn out the engine. You know, it's kind of hard to demonstrate, because if I had taken it a little bit further with the throttle or without the MW50 system, it just would have kept going. With the MW50 system, there's just enough of a cooling effect that it's going to help it stay right there, in conjunction with a radiator, which is also going to open. Yeah, that MW50 system is just going to allow you to firewall the throttle like this and not burn out the engine. So you always want to be careful not to firewall the throttle with the MW50 system disabled. Otherwise, yeah, you will eventually burn the whole thing out, and you will eventually burn out the engine firewalling it with the MW50 if you leave it engaged for too long. Now, just looking around for some more stuff to figure out here. I was looking at the fuel system. Right now, you can see on my gauge, I'm a little bit below a half a tank on my fuel, and the fuel system is actually very, very simple. We just have one big main tank right below me. I'm actually sitting on the tank right now. It kind of conforms to the shape of the seat, and that's where all the fuel is held. I can also carry a drop tank, which I want to do at some point. I want to especially try to take off with a drop tank and see what the effects are on the handling of the aircraft with that, and I want to jettison it also, just to play around. And there's also a feature built in where right here, if I have a drop tank and it's feeding, it might be modeled, it might not, but I would be able to see the fuel going through this little pipe right here. I might have actually misinterpreted what this line was. I was thinking this was the oxygen line, part of the oxygen system that fed back here into the main hose. I think this is part of the fuel system. That's the fuel drain line going into the, I think going from the drop tank into the main tank. I think I could be wrong on that. I think it's right there. I think I'm pointing at that part of it right there on the diagram. So if that were the case, no, that would just be the main tank feed line going down to the engine right there. So I don't know. I'll come back a little bit later once I think about that some more, and maybe find some real world documentation to tell me what this line is. But yeah, I know that if the drop tank is feeding, you're supposed to see something. Maybe it's like right there. It's kind of down further in that little gap, but you would be able to see the fuel flow. But yeah, fuel goes from the drop tank up to the main tank, and then the main tank just goes through it was basically fed by the two fuel pumps, which you can see pump 1 right here on the diagram, pump 2 right here on the diagram. So the two pumps draw fuel off the tank, and then they just provide it straight to the engine. So if I wanted to just use one pump or the other, like right now I've just got pump 2 engaged, it's still maintaining fuel pressure. If I go back to pump 1 only, it's still going to maintain pressure, and then I can just go back up to pump 1 and pump 2. So it's got a redundant system. If one pump does go down just due to mechanical or electrical failure or battle damage, I'll still have a backup to feed me with some fuel. And also, I have the ability to install in the MW50 tank, which is behind me, either the MW50 mixture or fuel. So I can use that as an auxiliary fuel source, and there's a switch right here, or like a control right here. So if I pull this out, that would shunt whatever's in the tank, MW50 tank, into the fuel tank. So yeah, there's that. Okay, so there's what I was just pointing at on the left side of the cockpit. There's the little pull handle right there. Goes back to this valve. It's like a little diverter valve. It either goes to the fuel tank or it just goes, diverts straight to the engine. That's where the MW50 would get injected. So if I pull that out, it provides fuel from the tank to the main tank. So that's how that works, and that's how the fuel system is set up. Now, let me see, oil system, that's pretty much self-contained. The only real control or real indications I have up here are oil pressure and oil temperature. And I would just know that, especially if I start to lose pressure, that I'm in trouble, or if the temperature starts to go up too high, that I'm in trouble. It has a radiator on the bottom of the aircraft that's going to provide cooling. So really not much to worry about on the oil except just watch the gauges. Everything is pretty much automatic when it comes to the temperatures. And then the coolant system itself. So we have 2 radiators on the bottom of the aircraft that we've already looked at in a little bit of detail as we were getting ready to take off there. We saw those in action, controlled by the switch right here. It has the automatic and the on and off position. So the more open the radiators are and the more airflow they have going over them, the better they're going to cool the system.